Good afternoon, everyone. My name is Eric with Bobcat Cam. I'm the demo tech here at Bobcat. So I normally do the demonstrations of the software program for potential customers, and I also do the tech support tickets for any customers that have any questions or concerns in the software program itself. And I've also been doing the live events here lately. The past few weeks, we were doing turning for a lathe. We were doing the new hole recognition and the milling functionality. And today we're going to be going through the Wire EDM programming here in Bobcat. We'll be taking a look at all of the operations, the functionality here in our standalone version, Bobcat version 35. We'll also take a look at the workflow if any of you guys are interested in looking at the programming for Bobcam for SolidWorks version 10 and our programming for Bobcam for Rhino version 3. So you can see I've got a part file opened already, and we can take a look at either doing the inside profile cut of this, the outside profile cut to either get the negative, the inside of it cut out, or get the blank of this. This is our workpiece. We could also take a look at an open shape cut that we may need to just cut one side of a shape and to cut on our Wire EDM machine. So basically, not going to waste any time here. We're going to go right into it. And if any of you guys have any questions, please let us know in the comment section, and I can answer them while we're following along with programming here. So we've got our 3D model, and looks like I've already got some additional layers here in my layers page. What I want to do is just kind of start fresh with my solid model. If I want the outline of it, the extracted edges to create this wireframe, I can right click in my layers page and go to add new layer. I can name it, I'll name it wireframe here. Make it a little larger so we can see the name of it. So we've got our wireframe layer, and it is active with that green check mark. So to create the wireframe from my solid, I can go to Create 2D and go to Extract Edges. And here's where I can either select certain surface edges, like if I just want this one edge, I can select the surface edge. If I don't want it, I can highlight it, delete it out of my selected geometry window here. I can pick the whole solid, which will give me the wireframe of the whole solid model, the top, the bottom surface edges, and also all of the edges along the corners there. I'm going to undo that and go back into my extract edges function. And I'm just going to pick the top surface here so that I have the wireframe from all of that. I also have an option to project to a certain Z-plane, so if I want it higher or lower than where it is, I can project it to a certain location in the Z-depth. But I want it right where it is, and that way I can hide the CAD layer, to hide the solid, and just show the wireframe when I'm done with it. Click OK. I'll hide the solid that's on the CAD layer, and I've got the wireframe layer with my wireframe that I just generated. So from here, we can start with, we'll do an outside profile cut of this shape out of a square blank. And to start with that, I'll go to the top with this cam tab, click on that tab there, and then go to a new job. And we have our Wire EDM settings here, and we can select what machine we're using. So if we have an Agi machine, Charmy, Fanuc controller that we're programming the G-code for, formatting the G-code for Fanuc, Mitsubishi, Sodic machines, We'll go back to that Mitsubishi machine that I was using here. We'll select the FA series here. And if you don't see your specific machine in here, you can go to our support page, that is bobcatsupport.com, to download a new post processor. And the post processor is the file that will format the G code specific to your machine. And if we don't have it on our support page, you can always email us with a post modification. If there's any modifications that need to be made, you can send us a sample program and a list of G and M codes and their functions, and we'd be able to format the post processor, format the G code specific to what you need. We'll go to the stock wizard next. And here we can define our workpiece, so we could see that in our simulation. Our next page, we can define our stock, whether it's rectangular piece of stock, if it's a cylindrical piece of stock. We could extrude it out from wireframe, select an existing solid model or STL model, or a revolved surfaces from wireframe. We'll select a rectangular piece of stock. We'll make it, right now it's 4.8 by 4.7. We'll make it 5 by 5 here. Give it a little extra amount of stock there. And we'll leave the thickness to what it is for our 3D model. Then our last page, if we go to the next button here, our last page is our machine setup. This is where we're defining our work offset at, our G54. So if we're setting everything at the bottom left corner of the stock here, as our G54 location, I would just click on that point, and that would be our G54 location in the G code. Now once we're done with that, we can right click on the machine setup and we have our different operations for the Wire EDM machine. We have our 2-axis and our 4-axis cuts. 2-axis inside profile cut, outside profile cut, or an open shape. And same thing for the 4-axis, inside, outside, or open. Since these are straight walls that we're going along, it's going to be a 2-axis cut. And I'm going to be just cutting from the outside, working my way along the profile, offsetting on the outside of the profile so that we have this solid shape to fall out of the stock. So I'll be selecting 2-axis outside and selecting my geometry. Now this is a good reason why I created the wireframe, so that I can hide the solid, and I can either window select everything here of my wireframe, or if I delete all of that selected geometry, I can hold Shift and click on one entity. I tend to do this, that way when I'm chain selecting, I know that I've selected a continuous chain. If the wireframe here is not a continuous chain for whatever reason, there will be a break in the geometry, and maybe I can do that real quickly here. Say if I, for whatever reason, maybe I accidentally trimmed up this line here, so there's a break in the geometry like this, a certain gap, so that when I'm selecting my geometry, chain selecting by holding Shift and clicking on a line, you can see that the chain selection ended right there. It's telling me that there's a break in the chain at that location. So that's why I tend to chain select all of my selections here. I just undid that, so now we have the correct geometry. But that's why I tend to chain select everything. That way, when I'm selecting my geometry, I chain select, and that way I know that I have a continuous chain and that I'm not going to get any issues with the toolpath, any issues with my G code at the machine. That is going to cut the whole shape there. So I'll click OK. I'll go to my next page. I can set the upper guide and lower guide here, whether I want to do a continuous taper. So we do have this option for Langdon taper option if we wanted to set that here, even in 2-axis, as long as it's a continuous taper all the way around the profile. For 4-axis, if we're cutting at a variable taper angle, we can do that as well with a solid model. So I'm going to select no taper with this one. It's just straight walls with the solid model. And then I can use glue stops with leads. So what this will do is when it will do the profile cut around, it will leave a little bit of material here as a tab to be cut later. So we can leave that. We'll leave it at 100,000 so we can see how that looks. So it'll do a rough cut with the tab left, and then so sometimes the machining order depends on certain customers. I know one customer I talked to said that they want to do the rough cut first, leave that tab, and then do the tab cut. So to cut the tab out next, and then a skim cut. So what I could do if I want to change the operation list, I can highlight the tab cut and move it up in the order with this up arrow to click on. So now we'll do the rough cut, the tab cut, and then the skim cut. Next page, we have some settings. These are all set up specifically for the Mitsubishi FA series, and these are all default settings for that machine. I can change them here if I want to. Change the feed rate, power setting, cut length, those kinds of options, the diameter for the wire to offset for rapid rate in the code. I can set all of those differently, or I can set default settings for my machine there. And then the tolerance level here, it's set to half a thou. I can change that here as well. The sorting order. So if I'm cutting out multiple shapes here, I can set the closest sorting order, no sorting where I can manually sort the shapes, or set it in an X or a Y direction. Then again, we can turn on the machine compensation or turn it off. So I can offset for the compensation of the wire, offset for the radius of the wire cut there. And so my next page is corner types. So if I'm going around the corners, I can break up the corners with a loop radius, different options like that. This doesn't always, I haven't had any customers use this before. I normally tell them this is very common with plasma machines, laser plasma, water jet, where they don't want to burn into the corners for too long, so they go off of the corners and loop around like that. And then we have our lead in and lead out page. So we can start at a parallel distance off of the part, perpendicular, circular options. I'm going to go with a parallel, lead in and lead out. And I'll do 1/4 of an inch. My lead in and my lead out. That'll update here. And so our next page, we can set up our own custom cutting conditions. Again, we can go into a table and we can set up our own power setting, offset, feed rate, all of those settings for next time. I'll just set the offset here. I'll set it at 10 thou. Power settings, feed rate, I'll go at 5 inches per minute here. Set the speed and tension of the wire. And again, if I go back to CAM, we have a cutting conditions page. So, no, sorry, that's going to be under Wire EDM. So under Wire EDM, we have our cutting conditions page. Depending on the material type, the stock thickness, and those settings here, we can set the wire diameter, we can set the power setting, offset, feed rate, so that we can set those cutting conditions depending on the stock thickness, material type for each time. We can set those custom settings by default there. So we'll go back to this page. We're at the cutting conditions page. We'll go to the next page for our tab cut. We have the compensation option again. We have our lead in and lead out. We have the cutting conditions again for the tab cut. I'll do the same 10 thou offset and 5 inches per minute feed rate. We can set the number of skim passes. And if we want to reverse skim passes, so if we're doing multiple ones, we can go back and forth with it. Set the machine compensation, corner types, lead in, lead out. I'll go to parallel again here. Do a 1/4 inch. And same cutting conditions, I'll do 10 thou and 5 inches per minute feed rate. So I'll hit compute. We've got the toolpath here in green. The green lines here are showing where the wire location is for each step along the profile there. And I can change the start point. Looks like it's starting here in this corner. Maybe if I wanted to start towards the middle, I can right click on the geometry option here in the cam tree and go to modify start point and select the start point here and click OK. And then I can right click on the feature EDM 2-axis outside and hit compute all toolpath again. And I would probably want to start in one of the corners. That way I can start outside of the stock and work my way in with the outside profile cut. So I'll start in this corner by modifying the start point. So right click on geometry, modify start point, and then I'll click on this corner here. Right click on EDM 2-axis outside and go to compute toolpath. Looks like there's not a whole lot of length here, lead in and lead out. Looks a little weird for the tab here, so maybe I'll start here in this corner. So I'll edit the start point again, go to this corner, try that out. Yeah, so it'll leave the tab there. Yeah, I know with my Wire EDM job that I have set up, I believe it starts here in this corner. Yeah, or starts in the center here. That way the tab will kind of stay right there in the center. And if you could imagine, if there was a hole already drilled through here, I can set that up. So let's do that. Let's set the start point here in the center so that we can leave the tab there. And for this shape, I have it for the stock that we started with. It was a bit thinner than the workpiece that I had. If I wanted to change the stock, I can always go into the stock option right here under Wire EDM job. Right click, go to stock wizard, and then maybe if I wanted it to be 1 inch, I can change that. And then we can go to our simulation by going to the top, going to start simulation. We can view the estimated cycle time. It says it will take 38 minutes and 59 seconds based on the feed rate that I have set. I can make the stock transparent so that I can see the cut here. And we can see the simulation here. If there's any questions that you guys have, please let me know in the comments section while we're viewing this simulation here. Okay, so I'll speed it up a little bit here. Going along the outside profile for this one. And then doing the skim pass here. So we can see right at the end of the cut here of the roughing by going to next stop. We can zoom in. Try to hide the tool here. And we'll show the stock. Let's see. Trying to see if we can get that tab cut. Okay, so the parallel, I believe, is going to cut away the tab. So to edit that, I'm going to go back to the lead in and lead out and make it perpendicular. And then we'll compute. Take a look at the simulation again to test that. What I like in version 35 with the simulation is it's its own window now. So now if I have two monitors, I can put this on my own on a different monitor while I'm programming in Bobcat on a different monitor. So that can be really useful. So here's the lead in right here, this perpendicular lead in, and then it'll do a perpendicular lead out and leave us that tab to be cut off in the next operation. So it's going to go around here. It's going to leave that tab, and then that is the next operation is that tab. And then now we're going through the skim pass. And again, you can change the machining order if you want to. If you wanted to do the rough and the skim, then the tab cut. But normally, yeah, with customers I've spoken with, you want to cut out that tab because the skim cut will cut it out for you anyway. All right, so we'll close out of simulation. And if everything looks good, we can set it up for the Mitsubishi machine. We can go to the top and hit post. It'll generate the G code for that specific machine here. And we can right click and go to save as and save it as an NC file to send for the Mitsubishi machine. If we're using an older machine with an RS-232 cable, we can right click in the window here, in the posting window, and go to NC Editor, where we can modify the G code. We'll always have an original copy here in Bobcat that we don't mess with, and then we can change the G code here if we need to. We can go to the top, go to Tools, and go to Start DNC Transfer, where you can set your port number, baud rate, and all of those settings to send or receive from the machine here. So we do have RS-232 communication as well. And so from here, everything looks good. We've got the outside profile cut. If we want to change to the inside profile cut, and then also look at the open profile cut for Wire EDM. And if we've got time, we'll take a look at the workflow in SolidWorks and in Rhino, but it's going to be the same workflow, which makes things really easy if you've got other people at your facility that are using other CAD software programs like SolidWorks or Rhino. You can do the same type of programming in the Bobcat standalone version here or in the other CAD programs, SolidWorks or Rhino. So we'll go back to the solid model here, you can see. And if we're cutting this shape out of a square shape, doing an inside profile cut, we'll go back to hiding the solid. We've got our wireframe, and that, again, from the beginning was going to create 2D and extracting edges for the wireframe of the solid. And I can go to Cam, start a new job, go to Wire EDM. This time, instead of Mitsubishi, I'll select Fanuc EDM. Go to my stock wizard. If I don't have a solid model, if I only have the drawing, I can skip the workpiece option here. And then I can go right to my stock page, define the stock parameters here. I'll make it 5 by 5 again. And then our last page is our machine setup, and this is where we're setting our work offset at. Okay, and then we right click on machine setup and we go to we go to 2-axis inside for this one. Select our geometry. and say we're just going to do a rough and a skim pass maybe, then I can turn off glue stop. So I'll say no glue stop. And then it'll just have the rough and the skim cut here. And then I'll skip these pages here. We can get to the cutting conditions, where we have our offset for the wire, feed rate, and then the parameters for the skim cut. I'm just going to do one skim pass again, and then my cutting conditions here. And hit compute. If you can imagine, we're going to basically just drill a hole here in the center and then cut around from there on the inside. So to do that, instead of having it here in this corner, I would right click on geometry, modify start point, click in the center here, okay, and then compute all toolpath again. Then we can go to our simulation. Takes a little time off, 38 minutes and 49 seconds. So that's telling us it only took an extra 10 seconds for that tab cut before. And now we're cutting the inside shape out of this rectangular piece of stock. And I can remove the intersection here by going to the measure tab down at the bottom right corner. And we have a drop down that says remove chips. I normally select this one, remove chips, and in parentheses select chips. And with my scroll wheel, I clicked on this center shape here, and it will fall out of the stock and show us exactly what's been cut here. And that was for my inside profile cut with the EDM machine. So we'll close out of simulation. And I'll delete this inside cut. So now we're back to where we have our wireframe with our stock. And if I right click and go to outside again, say I want to do an outside profile cut from here out to here. Sorry, chain select out to here. So if I wanted to do this chain selection and I selected 2-axis outside, you'll see that I don't have any toolpath once I've computed it. And the reason for that is because the outside and the inside 2-axis EDM cuts are for closed shapes. So that's the reason for our 2-axis open. And I can select an open shape like I just had. I want to do a no glue stops, and a couple options that I want to make sure of is I'm starting from the outside of the stock. So with my lead in and lead out, I'm going to go parallel, maybe like a 1/4 inch or maybe even a 1/2 inch, and my cutting conditions. Which is the skim cut. I'm only doing one skim pass. I'm doing a parallel lead in and lead out again, and cutting conditions. Compute. Here you can see it'll start here, work its way in, and do that open shape cut here. I can take a look at it in my simulation. And then with the rough and the skim pass here, says it will take 2 minutes and 57 seconds. You can also take a look at the cutout by going to measure here at the bottom right, selecting remove chips, select chips, clicking on this bottom shape with my scroll wheel, and that way I can see it being cut out, make sure everything's cut to size there, get to how I want it to look, and we can close out of simulation. Again, if that's the G-code that I wanted, I can go to post at the top, generate the G-code, right click in the posting window, go to save as, and then save it as any file type here. We'll save it as the file name here and save it onto a flash drive. If I want to change it from an NC file extension, I can do that by right-clicking on the Wire EDM job and going to Current Settings. And under EDM Posting, we have this NC file extension. And also Post Output if you wanted to output as an ISO code. You can select ISO and you can put in here .iso or any file extension that you need there. So that's about it with the 2-axis cutting here in V35. If you guys have any questions overall, please let me know. I guess one other tip to doing, we took a look at the wireframe option, but if we're working off of a solid here, we can go back. We'll start from the beginning by generating our stock, defining our machine setup, and then when we go into a say, for example, the 2-axis outside, when we're selecting our geometry, that wireframe can be really helpful, especially if we want to select multiple entities at a time, maybe that bottom cutout that I showed you. If we want to select a full chain, we can right-click on a solid edge here, and we have this constant Z and loop selection option when I'm right-clicking on a surface edge. This constant Z option will select all of the same surface edges in a constant Z level. So in this example, it'll select all of the same entities all the way around this shape, since it's all at the same Z location of Z0 here. We also have loop selection, which you can see all of the same entities are highlighted, and these 4 entities on this surface is highlighted as well. All these 4 entities are highlighted also. So if I selected one of these 4 entities, it'll pick up the rectangular shape, thinking that I want to cut out this rectangular surface shape. Or if I go back to loop selection and select one of the entities going along this chain selection, it'll chain select all of those entities for me. This is really helpful in the Wire EDM and especially helpful in milling, where you want to pick up a boundary like this. Rather than creating the wireframe, you can also do that loop selection option or constant Z option to be able to chain select surface edges when you're chain selecting surface edges for a boundary, for milling, or for a profile cut like this here in the Wire EDM module. Can be very helpful rather than having to pick up the specific wireframe from multiple surfaces. Especially the constant Z can be very helpful there. So other than that, I think that's all we're going to be going through in the V35, especially for Wire EDM. It's very straightforward. You've got either the inside or the outside profile cut in 2-axis or an open shape. And then with 4-axis, you're doing inside, outside, or open shapes. We're going to be going through the 4-axis Wire EDM module in another video. But just to kind of touch on it, when you're selecting the geometry here, you're selecting your upper profile, and then you're selecting your lower profile. You also have options for sync lines if you're going to sync the wire at a certain location. So say you're at each location, this surface edge, if there was a tapering to it, I would select that surface edge, and the software would know at these locations the wire is going to sync from this upper profile to this lower profile at this location with this surface edge. So those are the 3 options there in the 4-axis cuts: the upper profile, lower profile, and sync lines. But other than that, that's all we've got for the 2-axis cutting in V35. We'll also take a look at the workflow in our Bobcam for SolidWorks V10 and also the Bobcam for Rhino V3. So I'll save this part file real quick as a step file. It could be a step file IGES file, Rhino CAD file, DXF or DWG drawing, or it could also be a Bobcat file that you could import as a solid model like this and be able to work off of. So yeah, if you guys have any questions, please let me know in the comments section. I'm going to switch screens over to the SolidWorks program that I have up. All right, looks like we've got SolidWorks open, and I'm in SolidWorks 2023, and I'm in BobCam for SolidWorks version 10 that we're up on now. And you can see it's got the cam tree, very similar to the cam tree that we have in Bobcat version 35. We could open up a part file here. We could also open up a SolidWorks assembly file to work in. But I'm going to be working in a step file from Bobcat over to SolidWorks here. So we've got our part file here in SolidWorks. And we can go to back to the cam tree. So we've got our feature tree here in SolidWorks to create a sketch or a solid model here. And we can go to the cam manager and start a new job. Go to Wire EDM and define the machine. We'll select Sodic for this one and click OK. Then we've got our setting up our stock, whether it's rectangular, cylindrical, or any other shape, just like we have in Bobcat. And then we have our next page where we have our machine setup, again, setting up our G54 location. And just like in Bobcat, we can change our X or Y, Z directions or flip them here. And then click OK. Then we can right click and we have our 2-axis inside, outside, or open cut. And then we have our 4-axis inside, outside, or open cut. I'll select the outside for this one and select our geometry. Not sure what we would have for the chain selection. I think we still have options like that. We have select loop. Okay, yeah. So we do have the options similar to Bobcat, like the constant Z and the loop selection. So we'll right click on a surface edge and go to select loop in SolidWorks. And you can see this arrow is pointing down and the loop selection is this surface here. If I want to change it to, you could say, to a different plane, I would click on that arrow and it'll change to the loop selection to everything around that, basically on that plane that the arrow is pointing towards. If there was a tangency, I think it'll do that if I'm selecting something next to a curve or select something next to an arc or selecting an arc. Yeah, we do have a select tangency option, and it'll select everything tangent to that entity I selected. But since these are just lines that are going next in the selection, those aren't tangent, so it's not going to select everything. But we do have that option if you had a chain that was tangent to each other, you have your select tangency options too. So we'll select loop, click on the arrow, we got our loop selection there, and click OK. Our next page, we have our upper guide and lower guide. I'm looking at it and it says 1.27. That's because I'm in millimeters down here in SolidWorks, so I'm just going to finish this out. I'm going to change this from millimeters to inches. And now we're in inches again here. So we got our upper guide and lower guide. And again, same kind of workflow as in Bobcat. Taper settings, if we're setting a certain taper angle, using a tab so that the slug doesn't fall through, And if I want to do my tab cut before my skim cut, I can change the sorting here. We can set up the diameter of the wire so that it'll offset for that in our compensation, set the feed rate and all those settings here so that that could be set by default, setting a certain tolerance, setting our machine sequence. So if we're cutting out multiple shapes, again, we can do the closest shapes, setting it the closest sorting for the most optimized cut time. No sorting, so we can manually sort the shapes, set it in an X or Y direction. Turn on the compensation for the wire. Our next page, again, we've got these corner type options. So if we want to go around the corners with a loop radius, different options like that if we don't want to stall in the corners for too long. Our lead in and our lead out options. So we've got perpendicular, parallel, circular options here. We've also got an option to select point. So if we're cutting out many holes, if the holes are already drilled and we want to go around the holes, we can select the center point of all of the holes to be rethreaded at each of those locations here. So we have perpendicular, our cutting conditions. These are all linked to the database for SODIC automatically. And again, if we go back to, I think we'll right click on Wire EDM job. Just trying to find it here in, so in SolidWorks, you can right click on Wire EDM job and go to Edit Cutting Conditions. And that way you can change the material type and stock thickness and set the power setting, offset, feed rate, all of those settings by default for your cutting conditions here. These are all set up here by default for you. You've got your power setting 491, so I think the EPAC will be E491 is how it'll be output. We'll see that in the G code. Setting in the lead in and lead out, setting our cutting conditions, and then number of skim passes, corner types, lead in, lead out, and cutting conditions. So I'll hit compute, and then we'll take a look at the simulation. Well, first we'll zoom in and we can see the start point is here, up here in the corner. I want it towards the center here. And again, so I'll right click on geometry, go to modify start point, and I'll click on this center point of this line here again. And if I wanted to change direction, I can do that here. And then I'll right click on EDM 2-axis outside feature, go to compute toolpath. We can see the toolpath right there. And we can right click on Wire EDM job and go to simulation. And so we've got our simulation here. It says the cycle time, and we can run through it. There we go. Speed it up a little bit there. So here's the rough cut, and then the tab cut, and then the skim pass. Once everything's done, we can close out of the simulation. trying to find. There we go. So X out of the simulation there. And then after simulation looks good, we can right-click on Wire EDM job, go to Post. It'll generate the G-code in this posting window again. We can save it, put it onto a flash drive, send it over to the controller, or load it in our NC editor. So from there, yeah, I mean, it's the same workflow as we see, whether we're doing the outside profile cut like we just did, an open cut of an open shape, or an inside cut here. And other than that, I would say that's about it with programming in V10 for SolidWorks. And we'll open up, I'm going to open up Rhino, and then I'll switch screens to the Rhino software program that we're able to run in now as well. We're up to version 3 BobCam for Rhino. So that's really cool. If you guys are familiar with STL models, Rhino has a feature where you can convert STL models to a step file automatically. So that can be really helpful if you're doing any 3D printing and you want to modify a 3D model, or you want to do any kind of manipulation with 3D models, with STL models. You'll notice that they're not real surfaces or real geometry. It's just a mesh file once it gets to an STL. Rhino has the capability of being able to change an STL file into a step file so that you'd be able to modify the model from there and make any changes that you need, any dimensions that need to be changed, things like that. So it can be really useful there, especially for 3D printing. I know a lot of people use STLs for 3D printers. So I'll go back to opening the step file here. So I'm just changing the units here from millimeters to inch. That way it's a bit smaller there on my screen. And so we've got the solid model here in Rhino now to be programmed. And I can do that by going to the top, going to the tab for BobCam, and show BobCam. So it'll show my BobCam cam tree here on the left-hand side once that opens. So we've got our cam tree on the left-hand side. And again, same kind of workflow as in V35. We've made things very easy to be able to transition from BobCAD standalone version to BobCam for SolidWorks to here in BobCam for Rhino. You got your cam tree. You right-click on Cam Defaults and go to a new job. Select Wire EDM. Select your machine. Go to your stock wizard. You can define your workpiece. Next page, you can define your stock. We'll make it 5 inches by 5 inches again here. And then our last page is our machine setup, where we're setting our work offset, our G54 location. Then we can right-click on Machine Setup in the cam tree, and we'll do the 2-axis outside profile cut again. So select 2-axis outside, Select geometry. I wonder if we can right click on the surface edge just like the others. No, it doesn't look like it. The geometry selection is a little different here in Rhino. I might be able to chain select the wireframe though. No. Profile chain? No. Maybe not. The view is a little different. I'm holding the right click versus holding the scroll wheel in the other CAD software programs. A little different here. I think if I select the surface, it'll get the chain selection for me. Cut plot. Yeah, that looks good. I could select the surface there as well. So let's go back to the beginning. I'll delete this feature. So I'll right click on machine setup 1. I'll go to 2-axis outside. And for geometry selection, I can also select the surface here. The top surface there to go around, and I'll click OK. My next page, got our upper, lower guide options, taper setting, whether I'm doing leaving a tab there for the tab cut. Then I'll go to the next page. Again, I'll sort where I want to move the tab cut up in the operation list. So we've got our rough cut, where we're leaving a tab for the tab cut, and then a skim cut after all of it is done. We'll go to the next page. Our different settings here for the wire diameter, the power setting, feed rate, all of those settings here. Tolerance level. Machine sequence, we went over that a couple times, where I can set the closest sorting order to optimize the cut paths. No sorting, where I can sort multiple shapes manually, set it in an X or a Y direction. Then we get to our rough cut, turning on the compensation here. Setting the corner types. I want to break up the corners with a loop radius. Different options like that. Lead in, lead out. And cutting conditions here. Now say for example, after the tab cut here, and I'm setting the lead in, lead out, and cutting conditions with my skim pass, if I'm normally doing 2 skim passes here, for example, I can save that as a default now. So at the bottom here under save defaults, I can save all of these default settings. So I'm always doing 2 number of passes. I'm always setting up a certain lead in and lead out. I can save default settings here at the bottom. This can be really helpful with milling, especially like if I'm normally using a facing tool, for example. I don't have to change it from a 1/2-inch cutter every time. I can save a facing tool in the tool category list on the tool page there for my facing operation, so I don't have to change that every time. So that Save Defaults button down at the bottom, it's new, but it's not really flashy. It's hard to find, but it's very, very useful. We'll hit Compute down at the bottom here. It'll compute the tool path. And now it's cutting right here at the corner again. So I want to change it to the center. Can change that by right-clicking on Geometry, Modify Start Point, changing it to the center here, and hitting Compute. And then we can simulate that. Run through the simulation here. So this is the rough cut. And then right at the end here, try to catch it where it'll get right here. It'll leave that tab for the tab cut to come back and finish that. So here it is right at the end of the rough cut. It's leaving that 100,000ths of an inch tab there for the tab cut to come in at that same location, come in and cut off the tab to cut out that slug. And then it goes along with the skim cut for the next operation. And then the second skim cut as well. Then once everything's done, I can close out of simulation. I can right click on the Wire EDM job, go to post. It'll generate the G code here in the posting window. Or we can right click, save it onto a flash drive and save it onto the flash drive and run it on the machine from the flash drive. Or we can go into our NC editor and in the NC editor modify the G code or send it with an RS-232 cable. If we need to save it as an ISO file, again, we can right click on Wire EDM job, go to current settings, go to EDM posting, and change from G code to ISO file here. And also change the file extension from .nc to .iso or .cnc, .txt, whatever file extension that you need to save for your machine. And say if I did change it to ISO, just to show you guys, change it to ISO, click OK, right click on Wire EDM job and post. And then when I right click and go to save as, it'll save it as the file extension .iso for you. So that looks good. And yeah, if you don't have any other questions, I will give you guys some time back today, and we'll be looking forward to seeing you next week in our next video, our video series, our live events here. If you go to bobcadsupport.com, you can view our training schedule here. Under the training tab, you'll go to virtual training schedule. Going through the 2-axis wire EDM today and next week. I'm trying to see what we have for next week here. I believe we have it on Vimeo already. May, June. Oh, we're going to be going over 4 and 5-axis milling in the next week's some advanced features here in the 4-axis and 5-axis 4 and 5-axis pro milling operations to be able to get you some tips and tricks to work on that, as well as some other new features in Bobcat in the following weeks. And you can also review previous material, previous training sessions on that page on bobcatsupport.com under training. You can see the recorded live events as well. Other ones that we've gone over, like the one today, that were previously recorded, so you can go back and reference those in the meantime. And I'll stay for a couple minutes here in case you guys have any additional questions or comments here in the comment section. I can answer any questions that you guys have here, whether it pertains to Wire EDM or anything else in the Bobcat software programs here. I'll also give you guys here in the comment section our phone number for technical support. So for technical support, we have our phone number here and our email address. And so if you guys have any questions, please contact us at technical support. Our phone number is 727-489-0003. And our email is support@bobcat.com. So please let us know if you have any questions, comments, concerns, anything to help you guys out with the software program. We're more than happy to help. We're open Monday through Friday, 8 a.m. to 5 p.m. Eastern Time to answer any questions that you guys have moving forward. And if you have any questions, you can also let us know in the training live events here. We're more than happy to help you out moving forward. And thank you all for your time viewing the live event today with 2-axis Wire EDM. We took a look at our standalone version of Bobcat version 35. We also took a look at the plugins, our Bobcam for SolidWorks V10, and the one that I'm currently in right now is Bobcam for Rhino V3. And again, thank you guys for your time today, and hope you guys have a great rest of your day. Thank you. Take care.